Suppose we have a restaurant, and in that restaurant, we have a customer. That customer represents the LLM. What does the customer do? Look at the menu, chooses a dish, places an order, waits for the food. But what the customer doesn't do, enter the kitchen, cook food, worry about the ingredient or the recipes. Similarly, an LLM also doesn't execute code or access system directly. It simply decides what needs to be done based on the user's input. Now, when it comes to menu represents MCP. A menu tells the customer what dishes are available, what each dish does, how to order it, and it doesn't explain how the dish is cooked, which chef prepares it, what equipment is used. In the same way, MCP defines a standard, structured way to describe tools. MCP helps us list tools by clearly defining their names, what they do, and what inputs they need. So the LLM knows exactly how to use them without guessing. Now, here it comes to dish. And here dish represents to tool. For example, we have pasta, pizza, or salad. And if we take the example of tools, the very first one is fetch user data, read a file, call an external API, run a database query. The important rule here is if a dish is not on the menu, the customer cannot order it. Likewise, an LLM can only call the tools that MCP expose. This prevents hallucination and keeps interactions safe and predictable. Now, at last, kitchen comes in picture. This is where real cooking happens. Ingredients are stored, recipes are followed, and this kitchen represents the MCP server. And this is where the server executes the actual tool logic, manages authentication and secrets, talks to databases and APIs, handles validations and error. The customer here never sees the kitchen, and the LLM never sees implementation details or credentials.